All right, today, lesson 74, learning to solve absolute value equations. In the Bell work, we defined what absolute value is. Absolute value is?
The number's faces away from zero.
It's a number's distance from zero on the number line. So, absolute value is considered to be distance. Now, we can talk about distance of other things too. When you get it up into higher level mathematics, you can do the absolute value or the norm of a vector or the norm of a complex number. We could talk about the distance in space of a point, right? We could talk about the distance that the point 3, 2 is from the origin, right? So we could talk about the distance that things are. So there's a lot of different applications of absolute value, but they all have something in common. All right. So who can fill in this blank for us? Liam. Because absolute value is a number's distance from zero, there are blank numbers that have an absolute value of 3.
2.
2. All right, what are those two numbers?
3 and negative.
3 and negative 3 both have an absolute value from 0 that have a distance of 3. So 3 or negative 3. So solving absolute values are going to involve this line of thinking, all right? We're going to always be thinking of, okay, what is absolute value? If you see absolute value in an equation or you see absolute value in a problem, you got to be thinking about, we're talking about distance from 0. So most often, always with an asterisk, you'll see this in a little bit, two values that are going to work. Okay, so, for example, a simple equation like absolute value of x equals 7. Who could use the definition of absolute value to interpret this equation for us?
No, I can't.
Translate it into words.
X is 7.
X is a number whose distance from 0 is
7.
7. Right, and what you said was okay also. X is 7 units away from 0 on the number line. What does that mean x can be?
7 and 1 negative.
That's right. So absolute value of x equals 7. The number that we're talking about here, numbers that we're talking about, can either be x equals 7 or x equals negative 7. All right, so the solution, if we graphed the solution, and this is kind of boring to do so, 7 and negative 7, these 2 points right here have a distance from 0 that is 7 in both instances. Okay? Yes?
So, with inequalities, usually we graph, the greater than the open circle, but equals would always be close circle?
Yes. Yeah, if we're talking about equations, graphing equations, we'll always use closed circles to show show what it is. All right? So how can we take that logic to the next problem? Subtract what away from each side?
3.
Each side of what?
Just of the equation. Subtract 3, but then it'd be negative 19 though, wouldn't it? No.
No,
Because x plus negative 19 plus 30.
All right, no. Listen to Brooklyn.
Negative 19 plus 3 is
Negative 16, and that works, doesn't it?
So it'd be negative 19 and 13.
So what Brooklyn's saying is correct. Intuitively, the two solutions are negative 19 and 13. All right? Now, but if we're working with an equation like this, absolute value 2x plus 3 is equal to 17.8, you're not going to be able to use that logic. So what's the process that'll take us from the equation that we started with to those two solutions? Right? If our distance, we're saying that the distance of something, all right, this one thing here. Now, absolute value bars is a grouping symbol, so that's one thing. The distance of that thing from 0 is equal to what? The distance from this thing from 0 is equal to 16. So that means the thing inside here can be what?
16.
Or? Negative 16. That's right. X plus 3 equals 16, or x plus 3 is negative 16. Now, if you solve those two equations, you get x equals 13 from this equation, or x equals negative 19 from this equation. Now you could check this answer by making your substitution. 13 plus 3 is 16. Negative 19 plus 3 is negative 16. And both of those numbers do indeed have an absolute value of 16. Okay? So the process is that we're going to split things up. All right? Now, absolute value equations will always, and there's an asterisk there for a reason, they will always split, but not until the absolute value part is by itself. Okay? The absolute value equation is going to split things into two. All right? Remember we had this discussion with plus or minus? X squared equals 16. To solve that, you take the square root, right? Square root of 16 is just 4. But in order to make this positive, you have to use the absolute value of x. Is the square root of x squared is the absolute value of x. Now, what two numbers have an absolute value of 4?
4, negative 4.
Or negative 4. So that's where the plus or minus misunderstanding comes from. It comes from the absolute value. The absolute values are going to generally split into two separate problems. And I always with an asterisk. Got to be careful in math to use the word always. We're going to look at the two instances where they don't split. All right. And here's what we mean by getting it by itself. Close this window. 5 times the absolute value of x equals 20.
So you should divide by 5.
Can we or must we?
We must.
Yeah. If we're going to apply the definition of absolute value to this problem, we need to get the absolute value part by itself. So divide both sides by 5, and that will leave us with absolute value of x equals 4.
So then it will be, x could be
X is 4,
or negative 4.
or x is negative 4.
We have to graph it, don't we?
No.
Oh, we don't?
No, we never graph absolute value.
Well, I mean,
We don't generally graph the solutions to equations. It's a little bit kind of boring just to put points on a number line. Liam.
Do we have to show workflow like that since you can't see this?
Yeah, I want you to show the process. Now, the reason being is because if you don't have the process solid, when the problem gets more difficult, then you're going to flounder, okay, how do I do this? All right? So working through and being meticulous with easy problems is important to be able to do the difficult ones, because these are going to get much more complicated as the year rolls along. This is the first time we've seen it. You know how Saxon's going to build on this concept and make it more complex. First thing we're going to do here is, again, we have to get the absolute value part by itself before we can apply the definition of absolute value. So you'll divide both sides by 4, and that gives us absolute value of x minus 2 equals 20. And then we are going to split that. What are we going to get?
22.
Process. X minus 2 equals 20, or
Oh, process.
x minus 2 equals negative 20. This thing inside, we're treating it as a blob. What do we know about that blob?
Let's stick together.
That blob has to be 20, or that blob has to be negative 20. Because what's inside there gets more complicated, right? So x equals 22, x equals negative 18.
So that would be like, can we put x equals 22 in like a comma and negative 18, or can we throw it like that?
I'd prefer you not do that.
Okay.
You could use set notation. X is an element of
Oh, no.
the set, negative 22 or negative 18.
No, thank you.
Why? That's not difficult.
I don't know. I just can't do those little brackets and it stresses me out.
You can't draw?
Yeah, but in mathematics, if we're strictly speaking, and you loosely, that's kind of it's not really, the comma is not used in math for that. Commas are used to separate elements of sets, and sets are, sets have to be in brackets and braces rather, and going like that. Now, I wouldn't count this wrong, probably, but it's not technically correct.
Probably.
Probably. Depends on how aggravated I am with with Liam at that time. So it was probably I never get aggravated with you.
Yeah. Liam's been good today.
Liam's always good.
Okay.
All right, what do we do here?
Add 2.
We got to get the absolute value part by itself before we split anything. But when you add 2, what do you get here?
0.
The absolute value of x minus 6 is equal to 0. And this takes us back to our always in our definition. Remember we have the always with the asterisk. Can we split this into 2 different equations? We can't,
No, it's just 6.
because 0 doesn't have a negative. So this one just has one solution. And so if your distance is 0, then you're going to have one solution. Okay?
Oh.
Only 0 has a distance from 0 of 0. Now, if you were a little bit higher up the food chain in your mathematics, x squared minus 6 equals 0 in absolute value. That one's still going to have 2 solutions, plus or minus the square root of 6. But we're okay with, we're not going to see anything that looks like that.
That's good.
All right. But still, this equation wouldn't get separated into 2. It's only one equation, x squared minus 6 equals 0. But that equation happens to have 2 solutions. All right. We're not splitting it into 2. So absolute value equations always split into 2 unless it's equal to 0. What about this one?
So would it be x plus 4 equals 8 and then x plus 4 equals negative 8?
All right, so we've got a proposition on the table. X plus 4 equals negative 8 or x plus 4 equals positive 8. Now that makes sense based on what we've done up to this point.
It's not right.
But it's nonsense.
Alright,
Uh,
that's nice. So
All right.
it only has one solution.
All right, so let's solve this and see what you get. You get x equals negative 12. And plug that in. Is the absolute value of negative 12 plus 4 equal to negative 8?
No, because
How do you get an absolute value?
Oh no!
You have
Is
to
the
put a
absolute
negative
value of
in it.
negative 8 equal to negative
No,
8?
So there's
No.
no solution.
Okay, so can you think of anything that we could put in here that would give us a negative value out there?
No, you could put
Because absolute value is a distance. Absolute value is always positive. Okay, so what you have to do is recognize from the outset that this problem has no solutions.
The only way it could be positive is if there was a negative on the outside. I mean negative.
Right, now if we started with the negative on the outside, something like negative 2, and that was going to be what I showed you next, times x plus 1 equals negative 6.
Oh.
Then we would have to divide both sides by negative 2, and you get the absolute value equals 3. So we're not going to draw this conclusion until the absolute value is by itself. But the distance from 0 cannot be negative 8. It's not possible. All right? Even imaginary numbers that can take square roots of negative things, their absolute value is positive.
Do we have another example?
Yes.
Look at the back of my page.
One more.
Of course there's one more. We always have a word problem. And then try to use
All right.
thermostat.
Now, you know, there is actually quite a bit of real-life application of absolute value. Sometimes there's not. We're making things up sometimes to make it seem relevant, but this one is relevant.
It is?
Yeah. Well, no, absolute value is relevant. Not really. This example's kind of lame, but the thermostat in a classroom is set at 21 degrees Celsius. The thermostat will turn on or off if the recorded temperature is plus or minus 1.2 degrees Celsius of this setting. What are the maximum and minimum temperatures for this classroom?
What the heck?
That doesn't even seem like it's absolute value.
Yeah.
Right, but it is.
Oh, great. Really?
Okay, well, you're
Yeah.
Oh, 'cause the plus
It is
is-
because this is called, and you'll see this in chemistry, you'll see this in physics, and you see this a lot in manufacturing. This is a tolerance problem, okay? So if we're talking about tolerances, what is this saying? This is saying that the temperature can be within 1.2 degrees of
22 or
21. So our optimal temperature is 21.
Right.
The actual temperature will be within a distance of 1.2 degrees of that optimal temperature. All right, so the formula that comes out of this is to find maximums, we can use an equation, but the actual minus optimal.
I'm writing this down.
Yeah, you're going to need to know this.
21, right?
Actual minus the optimal, no, optimal is 21, has to be less than or equal to the tolerance. All right, now this is going to come into play later. Here our tolerance is 1.2. The actual temperature is X. All right, but we know that the actual minus the optimal has to be less than or equal to the tolerance of 1.2 degrees. Now, because this is what are the maximum and minimums, we're not worried about all the things in between, so we can just set it equal to 1.2. All right, and that's how absolute value comes into play. And later in the course, we're going to be doing some things with word problems that are actually less than or equal to deal. So here's an example of that. And when you're manufacturing a part, for example, a nut or bolt, y'all know what bolt is. These things have to screw onto, and you've got 20 of them here and 20 of them there, and they have to all be, none of them are exactly the same. It's impossible to produce something that is exactly the same. I mean, metal expands and contracts with temperature, but they have to all be within certain tolerances so they'll work together. And if a nut or a bolt is outside of those tolerances, it gets rejected. It's bad. Okay, and so tolerances have a lot of applications in manufacturing. Tolerances had something to do with the space shuttle, the first space shuttle blowing up, right? The temperature was not in the optimal range, and they knew it. The tolerances for that O-ring in that rocket booster, they knew it wasn't, that was outside of the temperature range for those O-rings on those things, but they launched anyway and it exploded. Sad. X minus 21 equals 1.2, or X minus 21 equals negative 1.2. Add 21 to both sides and you get X equals 22.2, or X equals 19.8. So that's the maximum and minimum temperatures for the classroom. Now it'll range all in between there, and that's where the less than or equal to comes in a little bit later in the class. But this does have something to do with absolute values. It's just kind of worded oddly. All right, your homework. And you can kind of, because this assignment is for non-honors classes as well. This is 1 through 9. And it's 11 through 14. And this is 20 through 25. Just to save you a little bit of time.